Hey everyone, I'm Justin Gray, and welcome to Chips and Tips with Chris Zappatini again. This is part 2 of our series, My Tool Library is Better Than Yours. Hey Chris, thanks for joining us again.
Yeah, I'm excited to be here, Justin.
Okay, so today we're going to we're going to keep going with our deep dive in on all things tool library, and we're going to be focusing
hmm
on the 4-digit tool ID number, right?
Right.
Okay. Why don't you kick us off there and tell us how you think about that ID number now?
Yeah. Um, the tool ID number, the way that I'm thinking about it is the rotating assembly, which is kind of what we touched on before and like in the community call and stuff. And so that is the cutting tool itself, holder, stick out, et cetera, et cetera. Like I guess call it and all that, depending on how deep you can actually like how much information you can put into it, like in your CAM system. But then obviously we have I guess not obviously, but we also have a spreadsheet that has like all of the information of the rotating assembly. So like what the tool number is, like what the part number of the tool is, all that information, the call it, the holder, if it has an extension, if that extension has a call it, blah blah blah. That's there.
Okay.
Um, yeah, and that is to, I mean, obviously to standardize to a certain extent, but also to track what we have going on. Um, in that, I mean, the tools, two potential modes and like schools of thought are I have this many tools available to me in my machine, so like 1 through 30, so I'm just going to use tools 1 through 30 always. And I think that's where the tool ID is like actually very important,
hmm
to knowing what is where and how you use it and when you use it, you know? And that
So
tool ID is like
for
is
clarity,
strict.
for clarity there,
Yes.
what you're driving at is that the tool ID is different from the tool number. And I think that's an important
Yes.
sort of separation there.
Yeah.
The TID is
Right.
like a stock number or a reference number. It allows you to pull up the BOM for that rotating assembly. It allows you to
hmm
track usage across different programs. If the tool number isn't
Yeah.
constant, like maybe it's tool 30 one time and tool 15 another, but it's always TID 0073.
Right. And it also, I mean, from a CAM standpoint, is like I know this assembly cuts this way in this material, you know, which is important because like I'm reworking somebody's tool library right now from Mastercam into Fusion,
Mm-hmm.
you know, and they have like a lot of different tool numbers. And like I mean, they're on a Datron, so the Datron's looking at like the part number of the tool, like what they call the article number,
Mm.
and that is what tracks in the machine. So if you have like tools 1 through 5, all have different cutting values and cutting information, and you use them a different way, but they all have the same article number. That is one tool to the Datron, and that's how they were getting around it in Mastercam, you know.
Mm-hmm.
Um, and but in Fusion, like, and then it just doesn't. The Datron just doesn't care about the tool number in CAM,
Oh, interesting.
but
Okay.
you know, which I find, yeah, it is very interesting. Which like this is information that I was like made aware of like right now. So I was like, I'm gonna rework some stuff. But that being said, the the important thing is this assembly and this tool sticking out this much and this holder cuts like this.
Right.
I have this cutting information. The tool number itself is irrelevant to the tool ID, which is important. Like when I was going through, because he gave me like 20 Mastercam files,
Mm-hmm.
to go through, and like the tool number just doesn't matter. Like it was just all over the place, and it's seemingly based on like as he was programming or whatever,
Mm-hmm.
what tool. So like the facing tool was tool 1 in the first program, and then like tool 6 in another one, and tool 2 in another one, and yada yada. And there was no clear designation other than like
But the
I like knew
article
enough,
number was
you
the
know?
same though.
Yeah. And I mean, I found that out after I like did the conversion,
Mm-hmm.
you know?
Mm-hmm.
But that being said, like there was no, like with the TID on the tool, like, cause they all stuck out the same amount. Like that makes that whole situation a lot easier when you're programming of like, oh, this is that one. I know what that is.
Right.
And it's like, it's not something else. It's not getting cut. Like the cutting parameters aren't any different. It's just a different tool number and maybe the assembly name is slightly different, blah blah blah.
Yeah. So I think that's a place in tool libraries where people can, I don't know, I guess I call it theory craft for a long time about like what the optimal tool numbering system is. And I think the
Right.
point of the TID is to sidestep that entire debate and say, listen, number your tools in your machines however you want, but the TID is
Yes.
just a sequential number. It has no meaning, and it allows you to
Hmm.
sort of like get a literally a unique ID, a tool ID, so that you know what that
Right.
tool is. And the value there is set. There's several key values. The first one is that it allows you to change your numbering scheme later on. Like if you start out with a fixed numbering scheme of like 1 through 10 are my core tools, and then
Hmm.
later on you decide to go to a different scheme where maybe 10 through 13 through 20 are your core tools or something. The
Hmm.
TIDs don't have to change. So it gives you that
Right.
flexibility. And then, like you said, I think there's also an important aspect of it of like they might have a couple of different quarter and gen mills in the same ER32 holder, but they could cut differently. Maybe
Hmm.
one's from Frasia and one's from Kennametal or something. And so you want different feeds and speeds, and you want a really unique way to identify that, even if they both happen to be tool 12 in different
Right.
programs. So I think that's the core concept of why the TID is the right way to go. How do you generate like unique sequential TIDs for your tool library?
How am I doing it right now?
Yeah.
Uh, I mean, for this guy, and for myself, I just started, TID one, done, next tool, TID 2, 0, 0, 0, 2, and that was it. I'm building it in Fusion,
Because
so it's
when
just like,
because you can sort by name in Fusion, and if the very first thing in the name is TID and a number, then it'll sort them by
mhm,
TID.
right.
So it's easy to know what the highest TID you have is and increment it one more.
Yeah.
Yeah.
I also, because I don't, like at the moment, I don't care about, the tool number itself.
Right.
In the like, I mean, one of the neato things about, I mean, I guess the tool library and this is kind of the same across like all can at least like, well, you can just use Mastercam and Fusion as an example, is like you have your library tool number and then the program tool number.
Right.
And so in the library tool, like I also just incremented that sequentially. So like as I'm building the tool, like tool 1 is TID 1, tool 38 is TID 38, and just going, and then in the file itself, it can be fucking whatever, it doesn't matter, but you change it there.
Yeah.
Um,
I do it a little differently. For me, because I already had sort of core tool numbers in my library that I wanted to keep,
mhm.
but I didn't pay attention to that when I made TIDs. So the TID and
Right.
the tool number don't match. And then the only things in my library that get permanent numbers are my core tools. Everything else I leave as a
Right.
zero so that it sort of reminds me
Yeah.
to assign a tool number when I put it in the program.
Right, right. Yeah, I mean that's kind of the same thing. Like when I was building fixtures, like 2 weeks ago, anything that I was like, as I was building, it's like, oh, this tap and this tap drill, those are gonna be core like standard tools always set up, so those get a number. And then I needed one drill that initially wasn't a standard drill, it was just an 8.5 millimeter drill, and built that, just left it without something, put it in tool 2 because as we've discussed before, like I have 2 through 20 as my open offsets,
Right.
for the floating tools. Again, doesn't actually fucking matter what that is, as
Mm-hmm.
long as it makes you comfortable. Like I don't think at that point there's like really no right way. Like the right way is the way that makes you money, you know?
Right.
And like that is just something I'm playing around with. But then when I kept going, and then I had to make another fixture. It's like, oh, 8.5 millimeter tap drill size for an M10 by 1.5, so that now becomes a standard tool. And just moved it in the spreadsheet or whatever to now it's this number. Done.
Yeah. So, I mean, I think that's really freeing. For me, anyway, it's really freeing. I would encourage people to think about TIDs as like not tool numbers. That way
Right.
I don't think about like, oh, what number should this be? And I don't stress about like what number should it be across all my programs anymore. Like what tool number should it be?
Right.
If it needs to be tool 14
Yeah.
today and tool 17 tomorrow, like fine. Um,
Yeah. Yeah. And that is obviously more of a problem on you can't play around with, I mean, there's certain machines where you're just not able to play around with these things. Like most of the mills with turret style tool changers, like you technically can fuck around with it, but it's just like cumbersome and not chill. Like Phoenix can do it if you have like tool management, because you can like turn it into a random style where it's like it creates a magazine out of the turret, and then you can kind of use tool types to put shit wherever you feel like. But people like just it kind of is brain breaking in that situation. It's also, again, it's just very cumbersome. Umbrella styles on Haas's, like you just can't fuck around with it. But on, you know, a Matsura or a Yazda or whatever, where you have like 90, 300 or like 330 tools, you can have a lot of shit just like in there, and which is the best. And you're like, well, these are all my standards. I just keep these built up. Like, I've yet to see hardly anybody use all of them for real, you know? I see like a lot of tools in places, but you'll see a lot of them like crusty dusty,
yeah.
you know?
Right.
Because they have no idea what is where.
Right.
Like it's where the lack of standardization and the abundance of tool positions like meet an impasse where like I don't know what's in what, and if it's built correctly or anything like that. Again, that's why TID sick.
Yeah, I never thought of that. That's a good point. So the idea is that it's in your library, and then hopefully because it's in your library, whether you're using something like Toolpath or like filtering in Fusion, I assume Mastercam has similar kind of filtering in a library. You can very quickly find tools that are the right purpose. And then similarly, if you have fixed TIDs, that allows you to, like you said, designate a certain number of tools as your floating tools, so that it can very quickly
Right.
like be taken out of the machine. Like, oh, I haven't used that in a while. I'll take it out of the machine, but it stays built up. And like you said, it's an advantage for things like on my Speedio, I can change the tool number on the turret. I don't like doing it
Right.
though. And so, yeah, for me, it's nice to then sort of have a unique number that doesn't depend on the number in the machine. Okay.
Yeah.
Let's talk about tool organization a little bit, because TID, if you're relying on the name sort for TID, then really the best thing to do is to keep all of your tools in one library, one folder, at least in Fusion.
Right. I mean, I guess the caveat there would be like for a specific thing.
For a specific machine, you
know,
mean?
Yeah, or a cell
Or
or,
a cell,
whatever.
yeah.
Like, because I mean, looking at this person's tool library, they have a Datron and a DMU 50, and use it like having one library for both of those things with like a running TID is just like kind of silly. Though I guess you could, I mean, if you wanted to take it a step further, you could make it like 6 digits or 7 digits, and like the first 3 digits are machine and the last 4 are your tool or whatever. And it's like, oh, it can get very
All right.
disgusting very quickly
So let's
to
say-
that point of being like,
Let's say you have two machines then, or two cells, whatever. Do the TIDs start at 1 for both of those?
I mean, I would say yes,
Okay.
probably,
All right. Interesting.
you know?
I would say yes, purely for convenience, but like theoretically, it'd be nice if TID
Right.
was like universally unique.
Yeah.
The CAM systems
Then,
don't make that
I mean-
easy, but
Right. I mean that is where it would get like very kind of yucky, I guess, because now you are maintaining two different libraries. Like trying to keep the like, oh, I did 1, 2, 3 over here, 4, 5, 6 over
Right.
here, and now I can't use 4, 5, 6 over here, and so I start 7, 8, 9 or whatever, and like, ugh, it's kind of yucky.
Right. Um, yeah, it's a fair point. I think still, ideally, it would be nice for the CAM systems to support a universal TID. If you have, for example, I don't know, two different machines, two VF2s with different spindles or something. They're both Cat 40, but one of them's a higher speed spindle. Uh, I guess you could argue that since the tool could move between those two, it could have the same TID and just different cutting data.
So I've had this conversation a couple times over the last week and a half, you know,
Mm-hmm.
and like about this exact scenario, specifically with a customer down in Texas that has like multiple Hermalas with different spindle speeds.
Mm-hmm.
And the way that they go about it is like they just treat them all as one. Like whether it's 20K or 18K, they're like it doesn't matter. That makes zero difference to us. We have one library that never goes above, like I think he said, like they say they'd never go above like 15 or 16 no matter what, so it just makes no difference at all. and and just consider it the same thing. I mean, that I would say where that would get a little silly is if like on the Haas side of things, if you have like an 8K and a 15K, that is like hard limiting, but more than likely you're probably going to have like a 12K and a 15K situation, or like in a robo drill scenario where you can have like the disparity is 10 or 24, which is absurd. I mean, it's just like is what it is. Like I personally, I think that you shouldn't buy a robo drill unless it's got a 24K spindle. Salespeople will say otherwise, like, "Oh, you're only cutting steel, whatever, whatever." It's like that the torque differential is not actually like big enough to fucking matter. But
Interesting.
you're always gonna want. There's always gonna be a situation where you're like, "Damn, I wish I had that RPM." You know, like, um, it's even if you're in like really little baby tools in steel, now you can exceed the 10K, and you're just totally limited. It's very yeah, but so then in that situation you could end up with two separate libraries, but or the other option is especially with something like Fusion where you have one library and then the cutting parameters, you have a 10K cutting parameter and a 24K cutting parameter. So it's you're maintaining the same library because the tools can switch over, but you just and like you do this around like templates or containers or whatever, and it's like like in this situation I'm going to use my 24K cutting parameters and still have the same TID for everything.
Yeah, I think ideally that's the way you would do it is if the same physical rotating assembly is going between two machines, but they have different uses in those machines, then you would handle that in cutting parameters.
Yeah.
If the same cutting tool is going into an ER32 collet holder, but it's a BT30 in one and a Cat 40 in another, those are different TIDs
Right.
because they're
Yeah.
physically different setups.
Yeah.
And similarly, if we say, we talked about this a little bit, I think, in the last one, but to go over it again, let's say you have the same tool holder, the same tool, same collet, everything, but you're adjusting stick out. Those are also different TIDs.
Yeah.
Yeah.
Yes. Yeah. I just wrote an email to the guy today as I like hit a good enough point of being like, here, like play with this and let me know what you think. And that was it's like what we're doing is like it's tracking. So we know that it's like in this case I use like tool one TID one, which is like a 6 millimeter by 6 millimeter like facing tool or whatever in the Neo. And it's if we needed for whatever reason to stick that out 3/4 of an inch, it's sticking out half an inch. If we needed to stick out 1 inch, then ideally we're creating tool TID 39
Right.
in that case, because now like going backwards, we want to make sure that like we know what we did before and then what we're doing going forward. Like, are we finding ourselves in a scenario where like that needs to be like kind of like standard, like more, and like the other one can kind of just fall off. We just see no difference in the half inch versus 3/4 inch. So it's like, why are we even maintaining this kind of thing?
Yeah, so a little bit of a detour, but it's a good detour. You just took us down there. This came up talking on our community call. Somebody said, "Well, how do I know how to standardize?" And first, the answer is you don't need to standardize everything right from the start, right? Like even if you just every time you use a tool assign a TID to it, you over time will get that data to decide like which ones matter and which ones don't. And if TID 7 was your half inch stick out and it turns out that you were totally fine using 3/4 of an inch and that becomes your standard,
Right.
like TID 7 can just go away. You never have to reuse it. Like it doesn't there's
Right.
enough numbers. So it just goes away. You just delete
Yeah.
it from your library. And
Right.
you say, all right, I'll
Right.
just always use the other one, right?
Yeah, it's the situation. I mean, it's just ABA, baby. Like, always be auditing. Like, I, I was with a customer. I mean, I visited a lot of people in Texas. I was there for like almost 2 weeks, and we just hammered out a bunch. It was a really good trip, but like, you get into this situation where it's like, what is the best way? What is the best way? And I mean, at a certain point, I mean, you know how I operate. I'm like, the best, like right now, we just need to like shut the fuck up and start cutting,
Right.
you know? Like that's the, like, what's it gonna do? What about this? Is like, we need to cut to know. And the same idea, the same principle with tool libraries is like, it's, oh, what's the best way to go? What's the best way? What's the best way? The best way is like, for like, just do it, you know? If you have nothing, doing anything again is better. So just like you said, this is like the situation that I did, where it's like TID one, even if I only saw like through the 20 programs, there was probably like 6 tools that repeated consistently through all of them. But it's like, well, I just add all of them to the library because I don't know, like if this is like this sample size or whatever. But it's not like it's not like we're locked in forever. Like, well, can't change. Fusion says no. Um, Once you make like the tools are uneditable, it's it's. I mean, I found it really funny, like on the community call, like there was just like a lot of haters, you know, and just general about the like, I can't standardize. I'm such a fucking like my shop is so special. I'm so special. I can't standardize for anything. And it's like, fucking relax,
Yeah.
you know. Um, there's absolutely a way to specialize or to standardize, right? While you're specialized. I mean, I would say like my like kind of gold standard for that would be Dylan, like, you know, in that she has quite a bit of standardization around a shop that almost never repeats work, and like a large run for him is like 10 parts, you know, with like a 3 to 5 day turnaround. He still has standard tools. He still has a fucking tool library, and he makes it work. It's like you put yourself in a situation potentially of like, well, I couldn't possibly standardize, and it's like I mean, some of the things we heard is like, well, what if my tool goes into a different holder? Why are you doing that? You know, like, why would you do that? But even still, to that point, and with the TID, if you have a tool that could go in potentially 4 different tool holders, right, with different stickouts or the same stickout even, but there's 4 different builds, as an example, having different TIDs for that in your tool library with different cutting data for all of them, so that you know, like, when I apply that fucking toolpath, it will work, is good. You know, there's no downside to that whatsoever. And it's like, will they all be built up? Maybe, you know, maybe not. And like, that's like kind of a separate thing a little bit. I know we, at one point we said like, if it's in the tool library, it needs to be built. We'll get to that one, but like right here right now, especially in that instance, like where you're cash strapped, you can't have all the holders, whatever, and you're always, for whatever reason, bouncing shit around. It still is better to have the library if you know you're going to build things a certain way, because in that situation, like almost all the people that complained like that were owner operators, single shop, like single guy, single machine, maybe two machines in some cases, where they are in control of their own destiny. And that is like an exception to the rule type of situation where it's like, yes, the company that I was at in Arizona that had five DMC 85, FD 85s, and like four DMU 100s or whatever with their tool library. It's like with a fucking tool room that was as big as my shop here, and not having enough shit. Like, what is the point of your tool library if you're not going to have your stuff built up? Like, there's levels to it. I mean,
I think
like,
that's
we
a key.
want hard and fast rules.
I think you hit a couple of key points though, and I want to summarize those so that we don't let them go.
Yeah.
The first one is, I think there's a feeling like a resistance to tool library because it feels very permanent. And when like you said, if hey, I'm always taking stuff out. I only have 10 holders. I'm not willing to invest in all these holders, so I don't want to build that tool library. I think that's a false economy because even if you build up those tools every time, you still get a ton of value out of the tool library and standardization, the speeds and speeds, all of that. The second one is that it's not permanent. If you need to change TID 7 because you find out, I actually need an extra 1/4 inch stick out, then change it. If you want to keep TID 7 with it in, and then you find out that but sometimes I use it with this other stick out, then create TID 38 and have it with this other stick out. If you have 4 different holders that you could use on the same tool, put them in the tool library. But if you stop using them or you find it's wrong, like you said, always be auditing, just delete them. And even if you only did that for, say, making up a number, the 10 most commonly used tools, you still get a huge win, right?
Right. Because ultimately the goal is the goal, but I mean, I'm just saying that like Eliyahu Goldratt is like throughput, right? Like, how do I get a program on the machine as fast as possible? How do I get that part off the machine as fast as possible and shipped as fast as possible? I think it is like it's what kill like first piece. The time to the machine is what can kill a shop, and then the first pass yield is what will kill a shop. And how hard you have to work for that first pass yield. Where if you don't I've personally seen shops struggle with this, as like when we were doing a turnkey and they were setting up a part behind us, and we the machine, because they had no tool library, they had no simulation or anything, they took every tool out of the machine and broke it down every single time, every time, and then rebuilt it up. So they had to step through parts every single time on their DVFs, and it's sure, you do prototype work, but it's you're probably gonna have a tool set up like this, and you're gonna cut this way, and if that's gonna work, it's the thing we say all the time: good parts, fast parts, good parts, fast parts. I don't really care how fast I can get the first part off the machine, as long as it's I'm not wasting time. It's there's fast and then there's efficient.
That's
and you want to be efficient.
I want to circle back to that. You don't care how long it takes you to get the first part off the machine, but you care a lot how long it takes you to get that part on the machine.
Yes.
That's the distinction. If it takes an extra half an hour or even an hour to finish the part, if you can walk away and do something else, awesome, right? But that requires you to be able to trust your sim, know that the tool matches. I just messed this up in my shop now. I had a reach situation and I changed the holder. I didn't sim it and it bit me. I didn't follow the process and it bit me. But if you follow the process and you model the holders and you sim stuff and you put it in your library, then you'll have reliable results to get the part on the machine. And look, maybe it won't be perfect. Maybe you'll have to tweak the program and go run it again. That's a different aspect of first part yield. But I think what you're arguing is that the time it takes you to get the first part off the machine, whether it's good or not, is your initial place to focus optimization, and that
Yeah.
the tool library and the TID system is like the easiest path toward that.
Right. It's because you start to like all of these things where you're like kind of guessing like this should cut like this should cut like that. You just start to like take it, um like you take that guesswork out. You're just reducing variables, and I mean obviously like it might not always be perfect. Like if the part is too thin or too thick, or the material, like like you have stressed out material and it just like some things you can't control everything. But like I don't know, I think about this from like a textbook I read in college, that like a like dialed in system is like truly dialed when you're down to when the only variables you're dealing with are like truly random variables, you know um and which is like, I mean, that's true, right? Like there's certain things you can control and then there's certain things that you can't control, like but like technically to a certain extent, like the stress of material as it comes into your shop, you don't know that until you cut it, right? Like you don't know how a piece of material is going to move until like whether like you could get same supplier, different batch numbers, same size, different days, and it's like this one was super stable and this one like potato chipped, and that sucks. But like that is just something that happens. But if you can control for everything else and the only thing you're dealing with is the potato chipping of a machine of the material, that's good, because like then that allows you to focus on one thing instead of, well, it's chattered, it's slow, it threw the part the first time, it did this, it did that, like my holes are blown out, like it's out of spec. Like if it's like the part is good except when I released it fucking potato chipped, okay, you can deal with that. That's a much like you can walk that back a lot easier than like, oh, I basically have to start fucking over because I programmed this from scratch, kind of thing.
Okay, so let's say somebody's listening to this and they have no tool library. Let's give them a recipe to follow. This is helpful like for people adopting lean or agile. Like you don't have to do it exactly this way, but if you don't know where to start, let's give them a recipe to follow. It starts with a TID system. I think it starts with
Yep.
one folder per machine or per cell, not necessarily per
Yeah.
material or per tool type though.
Right.
And then after that, it's make sure that the holder and the geometry match
Yep.
and assign sequential TID numbers. Don't be afraid
Yep.
to like use one and then delete it and never go back to it. Like just because there's a hole in your library for TID 7 doesn't mean you have to put a tool
Yeah.
back in there. In fact, you
Yeah.
should never reuse a TID number ever.
Right. And I would say like if we're going practical, like what we will often do is the when we decide, like if we're brought in and there's a decision being made, like, oh, they don't have a tool library, okay, we're making a tool library for them. Even if we never do work for them again, we build out the programs and stuff as if it's going to be a tool library. And so that being said, if somebody who has nothing is going to just start with the next program that you make, like just right there. Like that is like the next, I'm starting on job number 1, 2, 3, part number 4, 5, 6, and like the tool, if I'm going to use the tools that are in the machine already, okay, cool. So then I'm going to go out there, measure the tools, like see what I have, make sure that they match, give them a TID number, and then boom. That's because that's what I mean, when since we've started this conversation, I mean, and a little bit before, like when I set up my machine right here, like that's exactly what I did. And I did it on like the parts I was running are parts that I had ran before. And I just like before I posted it was like, I'm just going to go through, make sure everything matches and is correct. And then I didn't put the program on the control until I had like everything the way that I wanted it. And then as I went, it just made everything kind of easy because I was able to like go back and audit my other programs and apply what I had just done and made everything better. And it was fast.
I think
because
that's
I was doing my auditing in the tool definition instead of in the program, you know?
yeah. I think that's another key point. Sometimes the objection I'll hear is like, well, I have all this legacy stuff. I don't want to come up with a new system. None of my legacy stuff will work with it. And actually, that's fine. Like when you go to run that old program, if you want to run that old program using like no TIDs, you
Right.
want to build everything up, you want whatever, like whatever your old system was, you can keep using that for the old stuff.
Hmm.
But from you pick a point forward and you say, okay, program 1712 forward, these are going to use the
Yeah.
new system. And even if it's
I
the same
do.
physical tool existing in both systems, like that's also fine.
Right. I would say though, like I mean, there is that whole aspect of it of like um you could use your legacy system. I would I'm more the opposite, honestly.
Okay.
Of of um since we're doing this going forward, the it if the part comes back up, we we audit that part, convert it, and it's like it was running before. Like the amount of times, this is when I worked in a shop or I've seen other shops and like this, or we've gone brought in to do process improvement. Oh, this runs, and then you like watch it run and it's like, yeah, like we have to edit this and we have to edit that, and like the setup kind of sucks and we have to like do all this other stuff, and like but it runs, it works, the program works after they do like all this fucking work, and like it I've seen 4, 5, 6 iterations of the same part where it's like the first time every time, and it's like, well, we can't go back and fix it because it's working, but I would argue it's not working. And so there's a lot of cases like that, and it's like the whole this was the argument there, whereas like we need better standardization, and we don't have to go back and just start converting programs like spend like because that is a daunting task. But if if a part comes up and you're like, it's just convert it, you know
Yeah, you're making
convert it
the
over.
you're making the stop and fix argument, which it's hard to argue against. I think though
Yeah.
that it can create this daunting feeling. So let me revise my recommendation then, because I agree with you that if your part comes up again, and what you're describing is like people who have a broken process really need to fix it. But let's say
Right.
you had like a decent working process before. Just to keep it simple,
Hmm.
let's say you had a process bin with every tool you needed labeled, ready to go, but it just wasn't in your tool library system, right? And
Right.
somebody really could just load those tools into the machine, load the program, and hit go. You can keep that. Like you don't need to upgrade that to the new thing right away.
Right.
But if you have a bad process that's slowing you down, you should upgrade that. Here's my
Hmm.
revised version though. You can start the tool library program from like the next part forward. That doesn't mean you have to go out onto your floor and stop everything that's currently happening and like
Right.
interrupt processes
Yes.
that are rolling in place. If there's a production job
Yeah.
that's been going for 6 months, just keep it going. But
Yeah.
from this point forward, new stuff will use the new system.
Hmm.
Yeah.
Yeah. Correct. I like that. Yeah. And to that point, if it's already like, the nice thing about stuff that's already running is you can kind of like bust in and like fuck around, and then be like, oh, that didn't quite work the way I was expecting it to, and then just go back to how it was, which is always fun and nice. Not very often you get that type of situation, but it is good.
Okay. I think that covers like most of the basics for TID. Anything else?
Um, I don't know. I mean, there's, I don't think so. Like, I mean, the biggest thing is like, don't, as hard as this is to do, it's like, don't think of whatever you're doing as like a truly unique type of situation, because like I guarantee it's not, like, unless you're like, I mean, there are 1% type like shops or whatever, it's like we only do diamond turning or whatever, like it's like, okay, whatever, man. Like that's a different type of situation. But if like you're using a fucking hoss to cut parts, Like, I don't care what fucking material you're cutting. It doesn't fucking matter. Just make the library, like just start somewhere. And then like you don't like again, you don't have to burn the world down. Like you don't have to buy 1,000 tool holders right now. You don't have to buy any tool holders right now. You can use whatever you have, just like have some sort of commitment to like and like discipline towards like as I cut, if I'm using the same half-inch end mill and a side lock, or if I'm using it in an ER32 but I'm performing the same type of operation like OD roughing, for instance, like there should be different tool IDs, TIDs, because they are different, and you should have different cutting parameters to those, and then over time like um that will over time make you faster, which hopefully makes you money faster, because that's our goal is to make money. And this whole thing is to get money in, like, through the door faster, parts out the door, money into your pocket quicker, and then you can buy the tool holders and start to actually standardize.
I think there's a corollary to that, and this came up on the community call. Another point of resistance to this is if you really don't keep things built up and you just have a random assortment of tool holders, and
Yeah.
that's fine. That situation is by itself fine. But where people
Right.
will get frustrated is if in their head they know I just grab whatever ER32 call it, or 16 call it, or whatever is available, and I never build the tool the same way twice. They'll be very resistant to this idea. And look, if you want to run your shop that way, it's your shop. But like you said, the goal is throughput. The problem there is that you don't have enough constant in that system. You don't know how that tool is going
Yeah.
to cut. You can't rely on sim. And so
Right.
if you're listening to this and feeling like, oh, I'm no job I set up is the same, and that 3/8 inch end mill goes into a different holder every time I use it, like stop for a moment and ask yourself, like, okay, is it really not worth the $100 for me to buy a holder for this tool?
I mean, even stepping back to that, like, no spending no money. Is it really worth it not to like try and make the stick out somewhat the same every fucking time, Like, why? Like, it's such a non-scalable, like, it's so hard to scale a system like that, because you are essentially, I mean, your system is having no system. So bringing on employees is like extremely difficult, because it's like, well, build the tools. It's like, how do I build the tool? Well, just like throw stuff together and it should work. Like, I don't know. It's just like totally unsustainable
Yeah, so
in the
that's
long
the
run.
other.
And like, you can be a special little snowflake all you want, but like, I mean, you will probably max out at a certain threshold where you are 100% required for your business to operate all the time.
Right.
And that is like, what, I mean, what are we doing here? You know?
Yeah, I think you're getting at the heart of sort of the like underlying assumptions that you and I use to think about tool libraries, which is that like whatever your objections to our system are, and if you want to come up with a different system, like go ahead. But if your
Yeah.
fundamental objection is I can't standardize, then what you're
Yeah.
really saying is that I am willing to trade my time for saving money.
Right. Yeah.
And I am willing to accept a lack of scalability of my business. And I think like, as we try to make more parts, onshoring and all of those things, like that trade is not one that you can make if you want to run a scalable, profitable shop.
Right. Right.
And so this is maybe the most controversial thing I'll say in today's episode. Like I said, if you don't like our exact system, if you want to tweak it, if you don't like the TID system, or you want to go with, constant tool numbering or whatever,
Right.
fine.
Yeah.
But if you sit there and say, I cannot develop a standardized system, then I would argue that you're doing it wrong. That you are sacrificing profit.
Yeah. You're just like you're doing stuff in a way that is like, and you're intentionally doing it on hard mode to be like a cool guy, in my opinion. Like, there's actually no fucking reason not to do it. Even if like I have the same 3/8 end mill and I put it in ER16 and ER20 and ER25 and ER32, a side lock, whatever, like a big, like I put it in extensions. Cool. Like, every time you build that tool a different way, because if you're using that same fucking 3/8 end mill all the time, just save it. You're doing all the work already when you build it in Fusion or whatever, and like I'm guessing every time you build it, you're like, and you put it from a side lock into an ER32, and it's like, huh, it pulled out that time when I was roughing like it was in a side lock. That's weird. Like, you fucked yourself, right? It's like you probably break stuff fairly frequently, and if you don't, fine, whatever, man. But like, you also probably are like are leaning towards such a conservative approach that like it's like, well, no matter how I cut, if it's an ER16 or a solid holder, this will work. And it's like, well, you're you're doing the same type of work as building a tool library in without
Getting the benefit.
documenting it.
Yeah, you're getting no benefit.
Yeah, and so like you have no benefit of it. You did all the work to figure out what you're doing, and then didn't write it down. And
I think the
good job.
counter argument there would be I don't model any of my holders in CAM. So like,
Cool.
right?
Yeah,
Like,
and again, like it's and again, like I get it from like I don't have time to do it, which is like such fucking bullshit now, because like almost you can download a holder from anybody, and in like the case of Fusion, getting it into Fusion, like it might already be there, you can put it in there, but the amount of time you are wasting that you probably are like not thinking about with not modeling your holders is like the trade-off of building a tool. If you have to download it, put it in Fusion, and then run it through like Fusion Essentials or whatever, that's like what, like 5 minutes, you know? And now I have that forever. It's just done. And then I stuck it out an inch and I cut it this way, and that worked. So I saved that. That's like another, what, minute, you know? And now I have that forever. Like, if you're like, this is a situation like, oh, I needed it 1.1 here and 1 here and 1.25 here and 1.5 here, is like half of those don't matter, you know? It's like,
yeah, I think that's another
kind of,
place. That's another place where I would argue, like, listen, you're wasting more time than you realize. If you have the same end mill and you're adjusting it a tenth of an inch each time, like, unless you're making
yeah,
thousands and thousands of parts and just every last microsecond matters, fine. But
right.
you like pick a 3XD tool and a 10XD tool and start there.
To that point though, I would still say, like, and we do this too, is if you already have a library and you have, or like whatever, we're going to stick this out 1.5 inches, right? And we're going to make good parts. If we need to start squeezing time out, then you can start to like really hone in on stuff. But if you have a library already, it's like, I can make this part, I can make it good, you know? And it's like, oh, if I did this and I did that, I could, if I shorten this up 1/4 of an inch and I stuck this out a little bit further, if I had less flutes, but more shank, I could get more rigid here and yada, yada. Those are all compromises you can make afterwards,
Right.
you know? Because like the fact is that you don't know if you need that until the tool touches material, right? And then like in some cases, some of these changes are so minuscule, like as you saved 5% on a 5-minute roughing operation on an 1.5-hour part. How long did that fucking take, and how much money did that cost you to get optimized, you know? And again, if you're making tens of thousands of parts, sure, you know, a second over 1 million parts is like 2 weeks of time. Right. So like that matters. Who's doing that? Really? You know, now hardly anybody. And like, if you are doing that, you're probably kind of already in this zone, you know? I don't know anybody really who's doing like super high production work and they're a fucking mess. I mean, kind of. Like there's
It's
a
just
lot
a
of
different.
messes, but like
It's just
they
a
get it
different
done.
world. But I think
Yeah.
that's the key, though, is that a lot of times the resistance that I'll get to like standardization in a tool library, the snowflake argument is like, well, every job I do, I build my tools different. And the key point you're saying there is like, you could probably pick like your middle stick out of your 1/4 inch end mill and use that for 80% of your jobs, and then have one
Yeah.
longer 1/4 inch end mill that you use for all the other length stuff. and it would cost you almost nothing, save you a bunch of setup time, increase your time, or decrease your time to your first part. And it's a net benefit to everything. You need less tools, less holders, less thought process to programming a part. It's a win-win-win.
Yeah. And then like, I mean, like kind of like looping in what like Toolpath is doing, right, is the better your tool library is, the more likely you are to have like extremely good results. And if it's not optimized, like we eventually will do this, but we should do that now that I have my machine set up. Is like, what does it look like when you optimize a part like from scratch and you just start going versus using something like Toolpath to like just make me a program that I can just put in the machine and hit cycle start? I would bet money, like good money, that like assuming, right, obviously like templates and everything kind of come into play there, whatever, but like I would bet money if you're going from scratch and trying to optimize versus using something like Toolpath and just running it as is. Because like the thing that I think that the value that I see from Toolpath, I don't really give a fuck if it gives me a perfect program, you know? Like it just doesn't actually fucking matter if it's perfect. If it makes a good part, that is technically perfect because it made me a good part. It accomplished its goal of giving me a good program. Is it an optimized program? I don't care. Like if I could get the program, put my material in the machine, hit the button and walk away and come back to a good part, mission accomplished. And that's what I care about. You know, like you can optimize after it's fucking running, you know, like I think that's the biggest thing, is the optimization should be happening after it's fucking running, because that's free time now. The longer it takes you to put the part on the machine, the longer it takes you to get it into quality or to measuring it, the longer it takes you to getting it out the door. But if I can get it on the door, get it in the machine right now, off the machine right now, and measured right now, and then out the door right now, like there is no amount of optimization, like truly, that is going to make that situation better. You know, I could be 50% of optimized if it just check, first pass, out the door, win. Like versus, it took me an extra day and the program was too aggressive, I broke an in mill, and like, this kind of blew this out, and like I had to go back around. It's like, so your cycle time was like 2 minutes faster on like a 5-minute part. Cool. But like I shipped my part 2 days ago, so I don't fucking care how fast it was. Look, this doesn't matter.
Well, I think that's the tagline of the episode right there. If you don't take anything else from this episode, the tagline is the purpose of the tool library is to get your part on the machine and out the door faster. And if you don't think that makes you money, then we don't have anything else to offer you today.
Right. Yeah, true. Yes.
And if you find yourself resisting that idea, then take a step back and like, I don't know, measure it with a stopwatch or something, but like how much time did it take you to get, like how much time are you sinking into not having a tool library?
Right.
Because that's the time you could be spending on having a tool library and getting more parts out the door and making more money.
Yeah.
Cool. All right. Thanks, Zap.
Nice.
All right. Bye.
Bye.